Welcome to our class on YouTube, STEM Cafe. Here we make everything in science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and at the same time entertaining. Just to make it interesting. Today we are going to treat some questions, just to give you a bit of what we experienced in our class. These examples here are to show you the way to go. But we expect that your speed should be at least times 3 of what we do here. If you are going to sit for the tertiary examination, which is always multiple choice. Thank you and welcome. If the hypotenuse of a right angle isosceles triangle is 2, what is the length of each of the other sides? This is a right angle triangle. And it's isosceles, which means that this place and this place are equal. So this place you have been given to be 2. Straight, we know that a squared plus a squared is equal to 2 squared. So that is 2a squared is equal to 4. A squared is equal to 4 over 2, which is 2. So a equals to 2. That's it. This is a past question. JAM 1985, number 29. So once you meet it, you don't do all this in the examination. From here, you get your answer straight. That is that's what I'm trying to teach you. It's not that you don't know how to get the answer, but how to get it speedily. That's it. The ratio of the length of two similar rectangle blocks is 2 to 3. If the volume of the larger block is 351 cm3, then the volume of the other block is A 224 cm3, B 526.50 cm3. C 166 cm3, D 729.75 cm3, E 104.00 cm3. The ratio of the length is 2 to 3. Therefore, the ratio of the volume should be 2 cube to 3 cube. That is 8 to 27. So, volume of the larger block to volume of the smaller block is 8, which should be equal to 351 to V equal to 351 over 27 times 8. So E is now in the triangle XYZ, angle SKZ is 90 degrees. XK is equal to 15 cm, XZ is 25 cm, YK is 8 cm. Find the area of triangle XYZ. Straightforward. We know that this is. You don't need to go through this in the examination. All we need to find is this place. And how do we do that? Let's place this place. W. C. So W is equal to square root of 25 squared minus 15 squared. And that is 25 plus 15 into 25 minus 15. So that is 40 times 10, which is 400. So we know our W to be equal to square root of 400, which is 20 cm. So we can work everything out now. So our area of triangle XYZ is equal to half base times height. And what is our base? Our base is 8 plus 20. Everything is 28 centimeters. Is half times 28 times 15. And this is going to be 14 times 15, which is 7 times 30. This is 210 square. So the answer is B. So this is JAM question 1985, question number 33. Find the area of a regular hexagon inscribed in a sample of radius 8 cm. Answer A is 16 root 3 cm squared. B 96 root 3 cm squared. C 192 root 3 cm squared. D 16 cm squared. E 32 cm squared. So we have to find the area like this. It's regular. What does that say? They are equal. That is, all the sides are equal. So all we need is to find the area of one of the triangles. And when we find the area of one of the triangles, we multiply that one by 6. And that gives us the answer. Now let's go. For each, the angle 6 times one equilateral triangle of one isosceles triangle of 2 sides. It will be equilateral because all the angles are 60 degrees. So we are going to have something like this. Straight. 60 degrees. 60 degrees. 8 here. 8 here. So automatically this place will be 8 here. Because it is all the angles will be equal now. The area of this one. All I need is this. I'm going to find this. And how do I find this? This one is going to be 8 sine 60 degrees. So area is equal to half this times height, which is half times 8 times 8 sine 60 degrees, which is 32, which is 16 root 3. So the total area is going to be area of hexagon will be equal to 6 times area of triangle, which is 6 times 16 root 3, which is 96 root 3 straight. So JAM 1985, number 38. If cos theta is root 3 over 2 and theta is less than 90 degrees, that means it must be positive. Calculate cos 90 minus theta over sin square theta. From observation, you can easily deduce. If I were to do it, you know that theta is 30 degrees. So you can easily do it, or you break it down. Let's do it both ways. So you can say cos theta is equal to root 3 over 2, which is cos 30 degrees. Now sin theta is equal to sin 30 degrees, which is half. And you know what? So we can break that one down as cos 90 minus theta over sin square theta is equal to cos 90 minus theta is equal to tan theta over sin theta times sin theta. So this is going to give me cos theta. So I'm going to have 1 over cos theta sin theta, which is 1 over root 3 over 2 times half, which is 1 over root 3 over 4, which is 4 over root 3, which is 4 root 3 over 3. A solid sphere of radius 4 cm has a mass of 64 kg. Once you weigh the mass of a shell of the same metal whose internal and external radii are 2 cm and 3 cm respectively. The options are A 5 kg, 5 kg, B 16 kg, C 19 kg, D 25 kg, E 48 kg. Let's look at the first one. You are told that the radius of the solid, that is everything, radius is equal to 4 cm. Therefore, volume is equal to 1 over 3 pi 4 over 3 pi. Now, for the shell, the volume of the material, we are told that the internal and external radii, we have internal to external 3. So the volume of the shell itself is going to be the volume of the whole minus volume of the cup, So that is volume of shell is going to be 1 over 3 pi 3 cube minus 2 cube, which is 1 over 3 pi 27 minus 8, 1 over 3 pi 19, which is 19 over 3 pi. Now, we know one thing, that the mass will be proportional to the volume. The mass will be proportional to the volume. We are told that this one is 64 kilogram. Therefore, when V is equal to 64 over 3 pi, M is equal equal to 64. So when V, let's call this one V1. When V2 is equal to 19 over 3 pi, M is equal to, let's call it N2. Therefore, M2 over 19 over 3 pi is equal to 64 over 64 over 3 pi. Therefore, N will be equal to 64 times 19 over 3 pi divided by 64 over 3 pi. Now let's cancel. So this one is 19 kg. So the answer is C, 19 kg. You can easily cut this straight. You don't even need to get to this extent. But I did that to prevent questions. Now in the diagram, POQ is the diameter of the circle PQRS. If PSR is 145 degrees, find X. A 25 degrees, B 25 degrees, C 45 degrees, D 55 degrees, E 25 degrees. Whenever you are handling circle geometry like this, and it involves triangle or quadrilateral, always look for angle on the circumference and the angle of the and the angle at the center. This one at the center is double the one at the circumference. Just look for that one first. Then look for the ones in the same segment. If you can do that one, every other thing is simple. Now look at this. This one here will be equal to this one here. That's just the simple thing. Once you can establish that fact, every other thing becomes simple. This one is 180 degrees. So the one at the circumference is 90 degrees. So it means that this place to this place is 90 degrees. Therefore, 90 plus A is equal to 145. A is 145 minus 90, which is 55. Which is 55 degrees. That's it. Now, you know that A and X, they are the same because they are the same segment. X equals A. Angles in same segment. And where is the segment? Look at it. This is it. That's all. So, A is equal to 55. That's all. That's all. In the figure, PQ is the tangent from P to the circle QRS with SR as its diameter. If QPR, that is angle QPR, is equal to beta, and RQP, angle RQP, is equal to alpha, which of the following relationship between alpha and beta is correct? Relationship, please. Between alpha and beta is correct. Now, we can easily complete this triangle here. And this place is equal to 90. And from our circle geometry and triangles, we know that if this is tangent to this place, this angle here will also be equal to alpha. And we can now bring out something. We can now say, you know, this one is now, we have triangle in triangle SQP. Alpha plus 90 plus alpha plus beta is equal to 180. Therefore, I can say 2 alpha plus beta is equal to 180 minus 90, which is 90 degrees. Let's see if we have something like this. Therefore, I can say that beta over 4. If pi plus 9 root 3 over 4. Now let's look at it. What is the area? Now let's look at it like this. We have a sector. And this place is 120 degrees. But it is equilateral and it is isosceles triangle. So this place will be 30 degrees, 30 degrees. We have total of 180 degrees. But this place is 3 and 3. For the whole sector, area of sector is going to be 120 over 360 times pi r squared. That is 3 squared. Straight. For the triangle, very easy. Let's take it. We are going to have two triangles. And the triangle is going to be like this. This place will be 3. This place will be 30. This place will be 60. So, we are going to have this as base and this place as height. So, the area of this one is going to be half base times height. What is our base? Our base is 3 sine 60. Sure. Our base is 3 sine 60. Our height is 3 sine 30. So, we are going to have times 3 sine 60 times 3 sine 30. And that's going to be half times 3 squared times, what is sine 60? Root 3 over 2. What is sine 30? Half. And that's going to be half times 3 squared times root 3 over 2 times half. That is for one triangle. But we have two triangles. So, the area of the total triangle is going to be 2 times half times 3 squared times root 3 over 2 times half. Please, in the examination hall, you know how to get this one straight. That's how you practice. So I'm going to have 9 root 3 over 4. Now, area of the shaded segment will be area of the sector minus area of the triangle. Area of shaded part is equal to sector, area of sector minus area of triangle. Which is, and let me break it down. 3. Let me do like this. 5 over 3 times 9. So I'm going to have 9 into pi over 3 minus root 3 over 4. 3 pi. Okay, 9 pi. Let me give 9 pi over 3 minus 9 root 3 over 4. So this one is going to be 3. So on factorizing, I'm going to have 3 outside. And that's going to give me 3 into pi minus 3 root 3 over 4. So the answer is C. So you can get your answer very early. This is just for comprehension, please. In this diagram, we have 20, 80, 40, and x degrees. So we have to find x. At this point, let's call this place y. Angle at the point is 360 degrees. That is x plus y is equal to 360 degrees. This is y. That is angles at the point. So this is x, this is y. We are the one that puts y in. At the same time, you know that angles in equilateral is 360